Hey all, this is part one of our calorimetry lab, and what we want to look at is how much heat is transferred from hot to cold water. So you can see here my little calorimeter setup. I have a styrofoam cup to try to minimize heat loss. I have a stir bar inside here so that as we kind of evaluate these systems, we can distribute the heat as evenly as possible. If you're not using a stir bar with a stir plate, you need to figure out some way to stir it so that the heat gets evenly distributed and the temperature is a really good average temperature. You can also see I have my thermometer here, and then this is just a little, if it's gonna work, a little top, just again to try to minimize heat loss. So when you're looking at a calorimeter, the technique that you want to pay attention to would include minimizing heat loss, which we're going to do through, styrofoam and cardboard in our lab. The second thing would be the even distribution of heat inside of your container. So we're going to do that with a stir bar. You could also manually swirl or stir your system. And then the third thing is using the thermometer. So when we measure stuff with a thermometer, we want to be really cognizant of what the thermometer is touching, because whatever the thermometer is touching is going to influence the temperature. Is it touching the bottom of a hot plate, for example? If it is, then it's going to measure the temperature of the hot plate surface, not the temperature of your solution. Is it touching the sides of your container? If it is, then you could be measuring temperature that's kind of atmospheric temperature that's going through the sides of your container. So when we measure something with a thermometer, we want to make sure it's right in the middle of our solution and it's not touching the sides or the bottom, which could influence that temperature change. So for this one, it's a pretty simple setup. We're just going to measure some water that's cooler, water that's hot, and then we're going to mix the two. You want to make sure you have volumes and temperatures of all of your systems. So let's start with our cooler water. All right, that volume is going to be 53.5 milliliters. 53.5 milliliters for our cool water. We'll put that into our system here. Let's get this stir bar going. All right, and we want to measure the temperature of that system. We'll give it just a minute to kind of equalize. All right, right now it's reading at 21.7 degrees Celsius. We'll check that again once we kind of get everything else set up. All right, I also have some water going back here that you can see, and we're going to measure the temperature of that as well. All right, that system's at 93.5 degrees Celsius. And this one's still at 21.7. Okay, so now I'm going to measure out some of this hot water. And I want to do it kind of quickly so it doesn't cool down. Okay, I have 95.5 milliliters. Let's add the two together and we'll watch the temperature change. We want to record the highest temperature reached. It's 56, 50, 57, 57.5. 57.9, 58, right at 58. Okay, I'm going to write down 58.0 as our final temperature. Yeah, it started to drop now, just barely. So let's go with 58.0 as our final temperature. Okay, that is all the data you need for part 1.